Hi, everybody. Welcome to the third Mojo community meeting. We have an exciting program for today. Before we start, I want to put another call to all the members of community. It is very interesting to hear what you guys are working on. So please sign up. I know there are many more interesting projects out there than what we heard about. There are many future meetings. The agenda for the next meeting has empty slots. So if you'd like to share what you are working on, please sign up. Very simple format, 10-minute presentation, 5 minutes for questions. And with that, we'll switch to our first presentation for today, which will be talking about Mojo constraints. Okay.
Hi, can you hear me?
Yes.
Okay. Can you see the screen?
Yes, we can. Well, at least I can.
Yep, can see your screen.
Okay, cool. So, hi everyone. My name is Max. I like sandbox games, cellular automata, and robots. Online, I go by Hex, and I also have a website where I share some of the things I'm working on and stuff like that. So today, I'm going to be talking a little bit about Mojo constraints. So what are Mojo constraints? Well, sometimes we make mistakes. Knowing when and where something goes wrong is important. In Python, we have the assert keyword, which throws an assertion error if the expression is false. Mojo has assertion functions too, but Mojo is compiled. So what if something goes wrong during compilation? Well, we can use Mojo's parameter and type system to define compile time constraints. And just a little bit of the differences between assertions and constraints. Assertions provide runtime guarantees. They do that by raising an error or terminating the program. And they basically make guarantees about the program state as it's running. Constraints provide compile time guarantees. And they use the Mojo's parameter and type system to make guarantees about the compiled code. So to start things off, let's make a mistake. So let's just define 1 + 1 = 3. All right, that worked. Everything's good. We'll move on to some of the things you can do in Mojo. So in Mojo right now, we have debug assert, which will actually do nothing unless you compile the program with Mojo enable insertions defined. And you do that at compile time. When you're calling Mojo to compile the program or whatever. What this does is it terminates the program if the expression is false. So we defined 1 + 1 = 3. So, and we're making sure it equals 2 here. So if we run this, nothing's going to happen because I didn't compile it with Mojo enable insertions. But that's what that's for. So assert true. This is kind of a class of things. In Python, we you have the assert keyword, which is also similar, but there's kind of a class of functions in Mojo where you have things like assert true, assert false, and they basically work similar. They raise an error, they throw an error, and so this one, you can see there's an unhandled exception. because for some reason 1 + 1 = 3. And moving on to the actual thing that we're talking about today is constraints. So in Mojo, we also have a function called constrain. And what this will do is it'll actually fail to compile the program if the expression is false. And it uses the Mojo parameter system, which means the expression you give to this function must be resolvable at compile time, which is why I define this as an alias here. And if we run that, we get this nice error here, this compile error. And you can see 1 + 1 is supposed to equal 2. So that works. Okay, so a few things. What about branches? So the constraint function is a compile time only function. It gets reduced to nothing at runtime. So what happens if you call constrained in a dynamic branch? Well, in this example, we can see we have a function that's takes in a bool, and if that is true, it'll get constrained. Well, when I actually call it, it's false. So this shouldn't run, right? Well, if you actually run it, you can see it gives a compile time error. Must be true. So why does it do that? Well, Mojo doesn't know anything about that argument here, this condition argument, during compile time. So that branch may as well not exist. What that means is since runtime branches are basically transparent to constrained, it's good practice to call constrained at the top of a function, if that makes sense.
One aside, that stack trace error message is really horrible. This is something that the Mojo team need to invest.
It's a little verbose.
Yeah, that's.
Yeah, we're working on it. We know it's really bad. It's worse than C++ template errors, which is hilarious.
Makes me sad. Yeah, sorry to interrupt you.
Well, yeah, so that was a dynamic branch. So that argument wasn't known at compile time, but if we use Mojo's parameter system and pass it in as a parameter, that means we can branch this at compile time. So this is basically the same thing except using a parameter instead of an argument. If we run that, we can see it works. That's because the branch is at compile time, so it can figure that out. Something I also noticed, you can get this first version up here. You can get that to compile by adding always inline no debug decorator. I'm not sure if that's intended, but it only works because this right here, the thing that we're passing in, is a constant. So if I add the always inline decorator here, for some reason that works. Oops, yeah, that. I think that's because this is a constant, so it knows it at compile time. If you made this into a variable, it would still cause problems. So the next thing I want to talk about is redundancy. So if you just look at this example, I have a few functions. F1 is calling F2, which is calling F3, which is constrained. They all take parameters. So you have this chain, and at the very bottom, there's something that's constrained. Well, redundant calls are unnecessary. You can see the one below. We don't really need these. Essentially, these two cells do the exact same thing. but sometimes redundant constraints may be desired. If I just run these, you can see that this error message is it's even more verbose. So that's something, I guess that might not be a problem forever, but it's just something to keep in mind, I guess. The next thing is types and traits. Type and trait annotations are also constraints. They make guarantees about the program at compile time. So for this example, I just have a function that just takes in an int and does some stuff. So, but down here, I'm passing in a string. So that's there's an inconsistency here, and it won't compile. In fact, it gives you an error in the editor that tells you exactly what's going on. And that's basically leads me into the next thing, which is the visibility of these. So because constraints are handled at compile time, they can be made visible to the editor. Currently, constrain does not do this. If we define a parametric function and bind it to an invalid parameter, we don't see the error until we actually try to compile and compile a call to that function. So in this example, we just have a function that takes in a parameter as an int. And here, this is where we're binding that parameter to 0. And I guess it could be possible. I'm not really 100% sure on the details, but it could be possible to have an error visible here. And the only way to see that is really to just try to compile it, and then you see the error. So that's basically it. That's all I wanted to talk about today. If anyone has any questions or comments.
Cool. I think that I mean this is a great survey of what's going on here. I think we should totally look at investing and improving that error message and making sure that it dovetails with the IDE support.
Yeah.
I think that's a major issue. I don't know if anybody on the call happens to know, do we need to do anything specific to get it into the LSP the right way or something? I don't know how.
It's tricky because I mean, how much of the because that runs this error message comes later in.
Yeah.
Comes quite late, and it would be expensive to produce it in the LSP.
Oh, I see. Yeah, okay. Yeah, I see what you're saying.
Yeah, the other thing is that you have to call it, because if you don't, like, it might get DCE'd. I mean, even if you call it, it could get DCE'd, like dead code eliminated, and then it doesn't do the instantiation. And so you can end up in really weird cases where you call a function with invalid parameters, but then, you know, you're shuffling code around and gets DCE'd before it even ends up being instantiated. And then it gets even worse if, depending on the optimization level, more or less of these calls get DCE'd. So basically, it's really bad.
So for people who are not compiler nerds, when Jeff says DCE, what he means is that Mojo only generates code for the functions that get used. And so if
Yeah.
it actually
Okay.
use the function, it doesn't generate code. And this class of error messages gets produced when doing template instantiation. You can think of it as instantiating the functions with the parameters. And so that's why it doesn't come out.
Yeah, hella hex, if you want to try this out, if you go down to the bottom cell that you had, if you wrap
The
this
very
in,
bottom.
you wrap that func 0 in an if false, it's not going to produce the error, for example.
Yeah. Well, so let's
This
move
one?
to the next topic, just because we're a little bit tight on time and we have a number of topics. But this is a great survey, and it's great to go through this.
Okay.
Yeah, thanks for doing this.
How do I hang on?
Okay, thank you very much. Okay, so next, Valentin will talk about Lightbug.
Thanks. Hi, everyone. Let me pull up my presentation.
How do I stop sharing? Oh, there we go.
All right. Can you see my screen?
Yes.
All right. All right. Hi, everyone. I'm Valentin. Happy to tell you today about a simple Mojo HTTP framework I'm maintaining. It's called Lightbug. And yeah, I hope you enjoy. In case you haven't heard about or tried Lightbug, it's a simple web framework, a simple HTTP framework. It's not meant to be a big framework with lots of features, more like a simple toolkit to build your own frameworks with. Currently includes a pure Mojo implementation for an HTTP-based server, client, also pure Mojo, and a bunch of utilities for socket and network programming. There are also Python implementations for a server and a client, but we're not focusing on them. More interested in the Mojo bit. We'll get back to the slide in a bit. When building Lightbug, I was inspired by great low-level frameworks like Golang's Fast HTTP or Python Starlet, which, in case you haven't heard about them, Fast HTTP powers Go Fiber, for example, and Starlet powers Python Fast API, which I'm sure many in the Python world are familiar with. And also, I've been inspired by some smaller projects early on in the community, like Fire TCP by Jensen Holm, who were exploring this idea early on. Many people in the community, in the Mojo community, have liked the logo of Lightbug. Just wanted to say I generated it by asking ChatGPT to make one for me. And these are the other options that DALL-E generated. This bottom one is cute. Also wanted to say a huge thanks to the contributors who have helped make Lightbug better so far. You can see them here. For example, Michael's utilities from the Gojo library. He's implementing basically Golang standard library in Mojo, are used for string concatenation to improve performance, helping us be multiple times faster than if we would have been just concatenating strings. And Zach and Schmidt worked on a pure Mojo client implementation. Mozems created a packaging workflow for us, and Drew is working on a proposal for adding middleware to Lightbug, which I'm sure is also going to be great. And Jack is here because he helped them bump Lightbug to a new Mojo version at some point. Bit about me, I'm the main maintainer. I came up with the idea for Lightbug in December 2023 over the Christmas holidays. On December 31st of 2023, the repo was published. So for New Year's. I live in Vienna, work for a software startup here called Nexio. We're making software for data spaces, kind of sovereign data sharing. Like they say, to be able to say that you had a good life, you need to plant a tree, raise a child, and write the web framework. That's why I made Lightbug, of course. I mean, also because it's great fun. There's nothing yet available in Mojo for this. I wanted to write web applications, which I do mostly every day as a software developer. And this is also kind of solving my own problem, scratching my own itch. And this is not to brag, but more to show you that maybe the idea of having a web framework in Mojo is interesting for people in the Mojo community. In case you haven't seen this spreadsheet, that's Mojo repos. Basically, this is a spreadsheet also made by the community, which uses GitHub API to collect all the repositories on GitHub in Mojo. And this particular view is sorted by stars. So as you can see, Lightbug is pretty popular so far. It's kind of below the main Mojo repo, Llama 2, and Awesome Mojo. But in terms of framework, it's kind of the first. Hopefully, someone overtakes it soon. And also, Lightbug is not the only HTTP framework. There are other great projects out there, like also Michael has a Mojo HTTP client repository, which is arguably a better implementation of an HTTP client than the one you see in Lightbug. Also has a Gojo/net, and there are all these other repositories. I'm going to post a link to the slides in the community meeting doc, so you can check them out later. going back to the components of Lightbug, just gonna run through really quickly through the stuff that we have so far. So there's already a pure Mojo server implementation. By pure, I just mean that we are not using Python. We are calling C. We are mostly rely on Mojo. If you check out on GitHub, it's 95, 97% Mojo. Yeah, kind of a pure Mojo code base. You can already run a server listening on a port. You can create your own custom handlers by just implementing the trait. Looks like this. And then you can access the different objects, like to get the request body or headers, and you can use some convenience functions like this, for example, returns an OK HTTP response with the returning the body. You can already use the stuff that's there to set up some basic routing. There is no advanced routing yet, but you can do stuff like this. For example, this returns different things depending on the path that the user calls, let's say by making a request. And you can already serve static files. So the Mojo standard library utilities for file reading are pretty handy in here. So this handler, for example, serves an image. That's what you get actually if you set up Lightbug. If you run the default handler, it serves an HTML page with an embedded image with the Lightbug logo. This is done here by having these two routes. There's also a pure Mojo client implementation. You can make HTTP requests from Mojo. That's mostly community contributed. Kind of looks like this. You make a request, and then you can get access different parts of the response like this. This I'm just bringing some stuff to the console. And of course, all these different utilities like to do with socket programming, parsing headers, responses, all of that stuff. Also, feel free to steal and build your own web framework with this. So the performance, one of the main goals of building Lightbug, it's not so bad, I'd say. I'm pretty happy about it, but we're going to work to make it better. So for example, this shows basically that I used work utility to measure, to benchmark a bit. This basically is 22,700 requests per second. This is how it compares to frameworks like the Fast API, Starlet, and Express.js. As you can see, it's a bit less now, but also that's because we don't have any concurrency yet. These are, I took from a benchmark on the web, which uses 64 threads on the framework itself. And we're just running one thread. And this is if you add Rust to the picture. So quite
have you tried any of those with a single thread just to get the other baseline? This would be super.
No, but I should. Yeah,
that'd be super interesting.
I don't know why on the web no one does that. It always starts with 64.
Sorry, can you go back? I'm gonna ask you more annoying questions. It's kind of interesting. If you look at this just from like a cost perspective, right? Even if you're roughly the same as Express.js or Starlet or whatever, but you're 1/64th the cost. That's pretty huge if you think about it from that perspective, right? Because you're using 1/64th of the machine. So that's
hopefully,
really...
I mean, this is just a plain text handler. Of course, these frameworks, they have more functionality. We don't even have JSON serialization for now.
Okay, fair point. Yeah, but still, I mean, it's super interesting. Obviously, it's very early, but that's very promising.
Yeah, very promising. I agree. Oh, whoops. That's the journey so far. I'm not going to go into detail on that. Basically, opened the repo on December 31st, added the Mojo server, had some community contributions, added the Mojo client, and now we are really working hard on performance improvements. So we've been trying to get rid of all the like string concatenation, use more unsafe pointers, unsafe stuff, looking also at other frameworks like Fast HTTP, which don't do, let's say, any memory allocations in hot paths, trying to really prioritize performance. So hopefully we get there and overtake even maybe some of these frameworks. And for the future, I'd say top one priority now is concurrency as soon as we can add it. Haven't been able to do it so far. I mean, maybe there couldn't be a way to do it, but I've been waiting for more Mojo facilities for that, or let's say a runtime for async functions. I think there's been some additions to the standard library for this or coming up soon. So hopefully we add this soon. JSON serialization, of course, really the basics for web development. Who knows, maybe we get a Postgres driver at some point, then we'll maybe add that, but not necessarily in this core repo. SSL, I think, is important for production applications. HTTP 2 and 3, half of the web is on them, or more, probably more than half of the web is on them already. We are still on HTTP 1.1 and other stuff like WebSockets. And some of the more uncertain stuff is the Python standards like ASGI, WSGI. Not sure if we will implement them. Some people I've talked to think we should definitely to stay more Pythonic kind of, but it's still, yeah, curious to hear also what other people think. And then we'll maybe build frameworks on top of this simple repo, maybe to write APIs, or who knows, even like a more like a full stack web framework, but that's, yeah, of course, we can dream. All right, ready for the Q&A? Maybe if anyone has any thoughts or questions.
People are shy.
Well, my default question is, if no one wants to ask any, is like, what has been the experience of developing a web framework in Mojo compared to other languages?
I mean, it's been good actually. Of course, there's no facilities for like socket programming and stuff, but I expected that. And Mojo is a really fun language to program in. So as far as we could use external calls to C and kind of read a bit on how C works also, because I'm not a C programmer, it's been great actually. I enjoy coding in Mojo maybe more than even coding in Golang or other languages.
Cool. This is less of a question, but if we ever get a web server working with Tailwind and HTMX, we would give rise to the Moth stack, which is something that I feel like should happen just because of its name.
Moth stack. First time I hear about it.
The moth
Yeah.
gets thrown to the fire.
Oh, that also makes sense actually. Yeah, I mean, that shouldn't be too hard actually. Well, HTMX haven't used, but I mean, we're serving HTML already. There have been some community repos to kind of generate HTML in a more convenient way. Yeah, with Tailwind and others, it's a bit trickier because they depend a bit on all this JavaScript infrastructure, I think. But yeah, it would be interesting.
And another, I mean, so I'm a huge fan of this work. This is really cool. Another like very narrow thing. Have you thought about using def instead of fn?
I actually had in the very beginning, I had some defs in there.
Yeah.
And I think I recently switched all the tests to def because I saw that's how you do it in the standard repo. But I kind of wanted all the typization, the types of Mojo. But I can imagine like as soon as we get to like more like JSON serialization or the stuff where we don't know in advance what to expect, using defs would be really nice because like, yeah, we get all the advantages of kind of more dynamic style of programming. That would be interesting.
Yes.
Also to see how it impacts performance.
Yeah, so one of the things so theoretically switching to def shouldn't change performance, but it does force types. The other things it makes your functions throwing or raising by default. And so but it would allow you to get rid of a lot of our declarations and stuff like that too. We're talking about enabling implicit variable declarations for FNs to try to pull them closer together, but it would help clean up some of the code. And for the top level stuff, it might be nicer.
Oh, cool.
Or
I wonder like
early on defs had other problems, but those got fixed. So
yeah, that's cool. I wonder in general, in what direction will the community go in terms of like this more dynamic stuff, like JSON serialization, like, because you can go more Python way or you can go more like Rust way. Yeah, curious.
I mean, my hope is that it's more of right tool for the job rather than religious. Like, so if you're writing strings and you're writing, integers and stuff like this, then you want really low level control and things like this. But if you're writing scripting, then this is where Python is amazing, and this is where like the top level, just hack some stuff out, being very fluid is very valuable, I think. So
True. But that's also an advantage of Mojo, because you can do it like both
Right.
ways. So you can have it both ways.
yeah,
Which
but
is
we'll see.
very
And I think it's evolving for sure.
Yep. All right.
Okay, thank you, Valentin.
Thank
This
you.
was wonderful. Okay, so now Jack, going to you to talk about Python interop.
Thank you. You can see my screen, all right?
Yep.
Cool. All right, so this is the agenda. Got a lot of time here, so I think I can go through everything, but just yell out, Tatiana, if I got only 5 minutes left, and I'll jump to the demo at the end. So the first thing I'm going to show is Python interrupts change now. So instead of having to set Mojo Python library, if you're using something like Conda, it will just happen automatically. So the first one I'll show is all the different Pythons I have on path. So you can see these are all compatible with Mojo. And if Mojo in Python interrupt doesn't work for whatever reason, it'll send you a link to be able to run this script. So you can find a Python version that's compatible with Mojo. But most Python versions are compatible with Mojo. It's just ones that have a static libpython that don't work. So there might be some scenarios where it doesn't work. So I'm going to show you, this is what Python does. I'm just printing out the sys.path to show you where all the modules are coming from. So this is the Python version, and then there's a Mojo version here as well. So you can see they're exactly the same. Previously, this wasn't the exact same, so you get some issues with compatibility and things like that between different Python versions. And I'm just going to show you this demo of running this user interface that calls into Mojo. So I have this interface.py, and it's importing this custom tinctor. So if I try to run it from Mojo, it's going to import that Python file. So I try running this. It's going to say custom tinker isn't installed. So we're going to create a virtual environment. And then activate it. And then install custom tinker. So that's installed now, but the problem is that some packages, they rely on system dependencies. So at the moment, this won't work because I don't have TK installed from my system package manager, which is Brew, because I'm on Mac OS. So this is a problem because the Python version I have on top of path is 3.11. And if I want to install TK, Python TK, which is required for this to work, this is actually installing into the 3.12 environment. So what I can do is deactivate that and then create Python 3.12 virtual environment. And then activate that one. And then install custom tinctor into that. And now this will work. So you can see here I have this button clicked button, and it's just running a poll. So whenever the interface gets clicked, it'll run this Mojo function. So now I'm pressing hello Mojo, and you can see that this is like code from a Mojo file, and it's running in my terminal, hi from Mojo. Now the reason you need the system dependency is because it has this path that it adds that you can see down the bottom here. So that has a dynamic library that it installs. So this is the problem with pip installing things, like it doesn't sort out all your system dependencies. So one way to solve this is to use Anaconda. So I have a little script here for installing Anaconda, so I'll just run that. Now, the problem with Conda is it's pretty slow. You have to install like a lot of stuff. There's a lot of stuff to download. I'm just giving you a sense of the time, like how long it takes to do things with Conda, because there's better solutions. Cool. So now I'll just restart the shell. So Conda's on path, and then I can create an environment. So I use Python 3.8 for this one. And the good thing about Conda is that it sorts out all your system dependencies. So if I install custom Tinctor, oh, sorry, I got to activate it first. And then run the program, then it works just straight away. I don't have to install system dependencies with my package manager. But yeah, the problem with Conda is that, again, it's slow, but also like if you want to reproduce an environment, it's very difficult. If you want to show someone how to use your project, they got to run through all these different steps. It's just a bit of a pain. I'll just also show the paths in Mojo still work the exact same as Python. So anything you're doing in Python, all these paths will match the exact same. And it also adds like the directory for the file that you're running now, so that you get like, so you don't have to do that python.add to path anymore. So yeah, there are other solutions. There's like pyenv. So when you change directory into another environment, it'll just activate the Python environment, the Python version that you need for it. But this is also complicated, like showing someone how to reproduce all the steps to get like a reproducible environment is also very difficult. So there's this new one that I'm going to show you. And I created a little demo app running Llama 3 with Max. I'm using a GUI. And I'm also using this new one called Pixie, which is a much faster version of Conda. Has all the advantages of Conda, all the advantages of pyenv, and it interrupts with Conda and pip and everything that people are used to, but it's just a lot faster and a lot less steps. So this project here, I got this README. The only two things you have to do to completely reproduce the environment and get everything running is run these two steps. So I haven't installed Pixie. You don't need a Python on path or anything like that. Everything will just work in a reproducible way. So this is how long it takes to install Pixie. It's already installed. And now this is installing the dependencies and then running the project. You can see it started up this GUI here. And I have Llama 3. So when I click the Llama 3 button, it's just starting up a server with Llama 3. And this is calling into Mojo. This is like using Max. Take a little while to start up. Yeah, basically every Python environment works from Mojo now without having to do any extra steps. So you can try all the different ones and just let me know if you find anything that doesn't work. But this has started, so Llama 3 is ready, so I can ask it a question, go generate prime numbers with Python. And then it's giving me the response. So show me the code. And Llama 3 is actually pretty good. Also, it's using quantization Q4_K, which is very fast. You can see this is just running on CPU at the moment. We do have this experimental use GPU, which is coming soon. So if you have an NVIDIA graphics card, you can tick this and see if it's working for you. Also, I just built this demo on the weekend, so this isn't available publicly yet, but it will be soon.
Does it depend on anything weird, or is it just you need to get around to cleaning it up?
Yeah, I just need to raise a pull request. But yeah, everything's working, so let's see, just make sure everyone's happy with it first. Yeah, it gives you a really good description. Llama 3, I actually really like. It does a really good job for a local model. And it's also got the context of everything I have here. So if I say I wanted that to be up to the number 100, so I can say generate numbers up to 100. So it knows the context that I asked about prime numbers. I didn't put the prime number thing in this prompt here. It's just rerunning it, but instead generating numbers up to 100.
This is a huge amount of very complicated things all integrated together, Jack. This is pretty cool.
Great.
Yeah, like this is the thing, like Python has so many really cool things. And like building this was actually quite simple, just due to how good the Python ecosystem is. But yeah, like the problem is it's slow. So being able to call into Mojo from Python just makes it so that things are a lot better. But yeah, you can see this output now, it's generating prime numbers up to 100. So everything's working. And I can just show you what the file looks like. Like it's actually quite simple. It's using this library called Streamlit. Where is it? Llama 3. Oh, don't have it there. Yeah, so this is the entire script. It's only 100 lines of code. It does all this really cool stuff where you can like cache starting Llama 3. So if I actually change something, like I can change the text somewhere, I'll just find something to change. Like instead of calling that temperature, I can call it, bring this up on the side so you can see hot reload.
Can you crush the invalid Python interpreter boxes just so we can
Oh,
see them?
yes, yeah.
Sorry.
Set temperature. So when I press save, you'll see this update just here. You can see that's updated. So it's hot reload, and then I can still continue asking questions, like generate numbers to 200. And the server still started because it's cached, like starting up the server and everything, but you still get, oh, this is going a bit weird. It's generating something weird there. But yeah, like you can edit your interface in a really nice way, like you'd be used to if you're using JavaScript or Python, and everything hot reloads for you. And then yeah, the code is quite simple. It's only 120, what is it? 140 lines of code. So this would be a nice way for people to like build their own examples as well and like show using Max. And I've only got one here, like this is just Llama 3, but we'll obviously add like all the examples for all the different Max examples over time. Yeah, Llama 3 flipped out on that one, but for the most part it works. What else should I show? Just quickly, I'll show you what the TOML looks like. So this is creating like the reproducible environment. You can see I just have a task here that's streamlit run home.py. And so when you run this from the folder, it'll activate the Python version that's required and then install all the dependencies. Like you only have to run one command and it just does everything for you. So Pixie is like this new project that's really cool. It's very like if you've used Cargo before, it has all the things that people love about Cargo. But then also interops with like Conda ecosystem and PyPy ecosystem as well. So check it out if you haven't seen it before. Yeah, that's it. Does anyone have any questions?
I think we have a question from Adam there about Pixie. Is the main advantage of Pixie over more established alternatives like PDM Poetry, the handling of the system dependencies in the context of Mojo interop?
Yeah, so Poetry is good, except the problem is that it doesn't install like libpython and system dependencies. So that's the main issue. That Pixie solves that by like using the Conda ecosystem. So it'll create like a Conda environment, but locally to the folder. And then when you install it, like if you've already installed dependencies previously, they're all cached. So it'll just add them to your local folder. So yeah, there's a lot of benefits over those. I haven't really used PDM a lot. I haven't tried it, but yeah, I'll give that one a go and see what it's like as well. There's also this new one called Rye, which is also like Cargo inspired, which is quite good, but it does some weird stuff with like patching the binary so that it doesn't quite work with Mojo. You have to set a couple of environment variables. So yeah, Pixie like is the first one I've used where it just has absolutely everything I want and it works really well and it's really simple. So yeah, it's exciting for me. Any other questions?
Okay, Jack, thank you. That was absolutely awesome.
Yeah, no worries. Yeah, we'll get these examples up and share it all on Discord and all of that when it's ready.
Okay. We have a little bit of time left. So let me share the screen with the agenda. Okay. So we have some questions last time about async. We are going to talk about async at a later meeting, but I wanted to answer the question from Nick Smith. Jeff will answer the question, but okay. Does Mojo's approach to async require every function that might suspend to be marked as async or suspendable? If so, why? It would be good if we can avoid the function color and problem, which generates a lot of negative sentiment in languages that offer async await syntax.
So the kind of cop-out answer to this is Python compatibility. So in Python, async functions are colored. And so in Mojo, we copied the syntax and the semantics, give or take, from Python. That's the cop-out answer, because it's not really a real answer. To provide a more realistic answer, we can kind of look more into the future of async in Mojo rather than what the current state is, because the current state is trying to starting from the point of Python compatibility. So there's kind of two facets to this as you look at other languages like Go and Zig that generally manage to avoid this problem. One is one obvious way of avoiding function coloring in the sense of having two different kinds of functions is just to make all functions to be async. So I believe Go is a little bit like this, where you can use Go routines and channels in any function. The problem with this is that it has a runtime cost, and by making all functions suspendable by default, you only end up with one color, but it's still a different color than non-suspendable. And this has a cost, a runtime cost for all code. And because Mojo is also used for low-level programming and also GPU programming, this is not something that we can do in general. For example, the kind of async await in Mojo really is like CPU async await, and it's not going to work on GPUs. So we can't do this in general. The other approach is to infer the asyncness of a function from its body. This is more like what Zig does, but that's not something that Mojo will do, because our philosophy in terms of parsing is that the type of a function has to be known just from reading its like signature declaration. This is important for a lot of things: responsive tooling, lazy parsing, and compile time, and affects the scalability of compilation from the language. There's a couple of things, though, that we can do to kind of improve the situation. One bit of future work is that you still want to avoid duplicating APIs between sync and async. I think my opinion is that to get if an API is async or can be async, it should only be async, and that way you avoid the kind of API forking in many libraries where you get an async and sync version of an API. The other thing is, the more important thing is, if I have a higher order function, like let's say you want to std transform an iterator, and it's an async iterator, it would be nice to kind of have parametric asyncness, which is kind of similar-ish to how Zig does it, where we can write a function that is generic over whether the inner function is async, and then specialize all the async stuff away. And so that's one area, one future direction there. But in general, I guess, so the answer is basically twofold. One is Python compatibility, and two is performance, and both in terms of runtime performance and compile time, parsing, autocomplete, LSP, and all that stuff.
Yeah, and also I'd say that function colors get a lot of people. There's one specific blog post complaining about it, but the advantage, which you touched on earlier, Jeff, is the absence of the color. Right, and so knowing that something isn't async is actually really important, and that's actually powerful and useful for a variety of reasons.
Okay, we have another question from Valentin.
Should I spell it out?
Yeah, go for it.
Yeah, sorry. Yeah, basically kind of also related to my presentation. Maybe you want to open the floor a bit. I initially actually started developing Lightbug with HGI, WGI in mind. Kind of the question is about these Python standards, which are not maybe directly dependent on the technology, but more about conventions and yeah, kind of protocol standards that you can also do with pen and paper. What is the direction currently? Maybe in the standard lib, but also like in terms of what the community prefers. Do we want to be developing Mojo code in a way that's like close to Python standards like PEPs or HGI, WGI? Or is anyone trying to do that? Or what's the feeling?
Joe, Rob, and do either of you want to jump in?
Yeah, I mean, my first hot take response is that I don't think we have enough experience out in the wild to give guidance yet on whether to write async first libraries and how, if at all, we want to drift from Python. But I'd say stay tuned in the coming months, but I don't have a concrete guidance right now from my personal perspective, just from lack of experience out in the wild.
All right.
Yeah, I would add in, I think that one of the advantages that Mojo gives us to +1 Joe, and this is why we need to learn, is that the ability to reinvent a lot of libraries means that you get to learn from historical mistakes. And so you want to take the good parts that are learned from history, but then fix the bad parts. And then you have to decide, how bad does the bad part have to be worth breaking from familiarity and the past, right? And so I think last week we were talking, or last time we were talking about async IO, right? And Sam or somebody was bringing up the hey, if we're building file system API, maybe we should make it cloud native so that you can swap out the back end. And it's like, wow, okay, that's actually a profoundly good idea, and that's a thing that you really don't get a chance to retrofit into legacy IO APIs. But if you design for these principles from the beginning, then you say, okay, well, the great thing about doing that is that now you have a unified world on top of something consistent, and now you remove a lot of fragmentation and complexity from your ecosystem, right? And we have all of the Python ecosystem there, and so we don't have to worry about being compatible with it, but we want to bring forward the muscle memories and the design patterns and the good parts of this here, right? And so for async, I would think that using async natively is the right thing. There's tons of technical advantages to using async correctly for performance, for predictability, for eventually you build higher level abstractions on top of it, and I think you get a lot of safety and correctness benefits from that kind of stuff. But I think that the trade-off is that you don't want to get in a mode of being like, okay, well, let's reinvent everything and change everything just because I don't like the name of this one thing in this one place. It's like we want to keep some of the design decisions, even if you disagree with them, because it's worse to change them than it is to the benefit of fixing the problem or something.
Yeah, definitely. Makes a lot of sense. Thanks.
I mean, I think that's exactly the problem we struggle with the Mojo language too, right? Is we're saying, let's bring forward all the muscle memory. It's like, underbar, unbar, add. Like, it's such a funny, weird Pythonism thing to have underbar, unbar, add, but it's distinctly Python. It's a valuable thing. Bringing forward the familiarity is more valuable than fixing it. And so we say, okay, well, let's keep it the way it is, because what you're optimizing for is you're optimizing for the community, and you're optimizing for fluidity between Python and Mojo and stuff like this, instead of optimizing for just like theoretical beauty or minimal punctuation or things like that. So
good point.
But anyways, async, I mean, on that specific piece, I think, yeah, use async when it works. Because I think that's good for how computers work, and that's good for network services and stuff like that.
Yeah, specifically in a couple of weeks, once we're a little bit further along with some async improvements that need to happen in the compiler and the language, I do encourage you to play with it and start getting experience out in the wild with these async first APIs from Mojo library perspective, and feedback in feature requests and what works, what doesn't, to help give guidance. You can definitely trailblaze in that path if you'd like to.
Okay, we have time for at least one more question. Gabriel.
Yeah, sure. This is a question to Jeff specifically. So yeah, when we worked on UINT, the type, it was said that we would prefer to use MLA and index instead of an alias to UINT32 or UINT64, and we had a bit of a justification, like it's like the compiler likes it better, roughly. But I would love to have a more detailed explanation on like why do we need something else than an alias if it's represented internally the same way.
So first I'll start off with a meta point in that I think we should have a I don't know if this bi-weekly meeting is the right place, but we need some kind of design meeting that we can have between Modular and, well, I won't say within the greater Mojo community. That's not just Modular. I think this is a discussion that could have been had that didn't have to be internal. Now, I assume it was done internally out of abundance of caution of what could get discussed. And there were things that were discussed that probably would not have been mentioned in a more open meeting. But I think for the future, this is probably something that we could be more transparent about and include the community a bit more. So
yeah, just here, feel free to, like, if you don't want to organize something because it's a lot of time to organize things, feel free sometimes to just record meetings. And if you know that there wasn't anything like secret being said, you can just release the recording.
I think next time we'll be more judicious with like making it an open versus closed like design discussion, especially when it comes to open source standard library things. But I'll kind of summarize what we touched upon in this discussion. One is that, yeah, the compiler likes index better, for better or worse. And for those who've seen the kind of pop dialect bits in the standard library, we're kind of juggling two type systems inside the compiler. One is this pop D type based type system, and the other one is this MLIR built-in type system. This is like awkward for a lot of reasons, but as things currently stand, it's a lot better just to use MLR index for a lot of things. It's better for optimizations. There's a lot more things work on index. The other reason is actually that this like conditional alias to UINT32 and UINT64 just would not have worked, because the target information is not known until later in the pipeline, because we start with a target agnostic section in the compiler. This way we can, retarget our IR. So we're not like C++ where the target is known during parsing. What this means is that the type will not be known during parsing. And so if you make this a conditional alias, the compiler actually, or the parser will complain that it doesn't know actually what the type is, whether it's a UINT32 or a UINT64. The actual reason is that it's not going to work. But I mean, assuming, in terms of like completing the train of thought, it's better for the compiler. And there's a lot of other specific internal reasons why these kind of very load-bearing types need to be in MLR index.
Okay, thank you, Jeff.
Can you give him concrete answer of like what to do? Because I think that's probably what he's.
Oh, I believe this work has already moved forward. I think it's landed already, right?
Yeah, the PR is being merged already, and we went for the index. Like it was already written this way, because the issue was written this way. Like it said, just choose the unsigned variants, and that's what I did.
+1 to more open discussions with like the modular and external community with the core contributors, with the standard library. In this case, it was just a matter of expedience, just because you were out on your on-site and then we wanted to move forward on this work before we were out on our on-site. So just FYI there.
Oh, nice. We have you. That's awesome. Sorry.
Thank you, Gabriel.
Thank you, Gabriel. We are out of time, so we'll finish right now. And we have one more question that will be carried over for the next meeting. And I think maybe it will be a regular part of every meeting to give chance.
I can quickly answer this last question within the next 3 months.
Okay.
It's a priority. Cool. But why don't we pull it forward and we can have a longer discussion on it next time? Thanks all. Bye.
Okay, thank you.
Cheers.